Welcome to a video on calculating OR probabilities using contingency tables. In this video, we will focus on understanding mutually exclusive and non-mutually exclusive events and how to calculate their probabilities. Let's get started. Throughout this video, we'll be using the contingency table that compares study method versus grade. You can find a link to this contingency table in the video description below. This table contains the results of a survey that was conducted on a group of students regarding their preferred study method, flashcards or practice tests, and their average test grade of A, B, or C. For these problems, we will assume that a student is selected at random and we'll find the following probabilities. Before we get to that, let's review what it means to be mutually exclusive and how to use the addition rule for probability. Two events, A and B, are said to be mutually exclusive if they cannot occur at the same time. If A and B are mutually exclusive, then define the probability of event A or event B occurring, which is the same as the probability of the union of A with B. Just calculate the probability of event A occurring and add it to the probability of event B occurring. To calculate OR probabilities, we use what is called the addition rule. So OR is usually tied to addition in probability. Two events A and B are not mutually exclusive, then they can occur together. In this case, the probability that event A or B will occur is given by the probability of A or B occurring. That's the same as the probability of A union B, and that's equal to the probability of event A occurring plus the probability of event B occurring minus the probability of the intersection of A and B. In this case, we are still using the addition rule here. However, you should notice the subtraction on the end. The subtraction accounts for the overlap where both events happen at the same time. We'll take a look at this in some example problems. Here's our first example. Let's find the probability that a randomly selected student received an A or received a B. As soon as we see that phrase or connecting the two events, we're thinking we need to use the addition rule for probability. Before we can use the addition rule, we need to determine if these events are mutually exclusive or are not mutually exclusive. Let's find where these events are located in the table. So we see that there is a column for all students who received an average grade of A, and another column where students indicated they had an average test score of a C. Notice that these two columns do not overlap. And also, if you think about it, a student cannot have an average test grade of an A and a C at the same time. These events cannot occur at the same time, so these events are mutually exclusive. Mutually exclusive means that the events cannot occur at the same time. When you're given a contingency table, you can see that you have mutually exclusive events because they will not overlap or intersect. So to find the probability a student received an A or a C, all we need to do is find the probability that the student received an A and add that to the probability that they received a C. Looking at our table, we see 29 out of 72 students received an A. So the probability that a student received an A is 29 out of 72. Now let's add that to the probability that the student received a C. From our table, we see 27 students received a C out of 72 total. So the probability a student received a C is 27 out of 72. Now let's use our calculator to add these two fractions together and then convert it to a decimal. As a fraction, this would add to 56 out of 72. As a decimal, rounded to 4 places, this would be 0.7778. As a percentage, this would be 77.78%. For our next example, let's find the probability that a randomly selected student uses flashcards or received a C. Once again, there's that phrase or that usually tips us off that we're going to need to use the addition rule. But before we can use the addition rule, we need to ask ourselves whether these two events, using flashcards and receiving a C, is mutually exclusive. Let's first find this information in the table. We can see there is a row of our table that contains information about students who indicated that their preferred study method was using flashcards. And there's a column in this table where students indicated they received a C test grade. We can see that this row and this column do in fact intersect. That's because these events are not mutually exclusive. A student can use flashcards and receive a C average test grade. If the events overlap, then they are not mutually exclusive because they can occur at the same time. Since these events are not mutually exclusive, we will do addition and subtraction here. So to find the probability that the student uses flashcards or received a C average test grade, we're going to find the probability that the student indicates they use flashcards, add that to the probability that the student could have earned a C, and then we subtract the probability that the student uses flashcards and received a C, because this is where the two overlap, and these students end up getting double counted. So the subtraction helps us eliminate the double count. Let's find the probability that the student uses flashcards. From the table, we see that there were 22 students who used flashcards out of 72 students total. So the probability a student uses flashcards is 22 out of 72. Now let's find the probability that the student received a C test grade. Looking at the table, there are 27 students who earned a C out of 72 students total. So the probability that a student earned a C is 27 out of 72. Now let's find the probability that the student uses flashcards and earned a C. From our table, we see that there are 8 students that fall into this category out of 72 total. So we will finish this problem by subtracting 8 out of 72. Essentially, these 8 students were counted twice. They were first counted because they're part of the 22 students who used flashcards, and they were counted a second time because they're part of the 27 students who earned a C. So we subtract out 8 out of 72 to offset our double count with the 2 probabilities we found earlier. Let's use our calculator to total this up. Using our calculator to add and subtract these 3 fractions, we get 41 out of 72. Or to a decimal rounded to 4 decimal places, this would be 0.5694. As a percentage, this would be 56.94%. Let's summarize. To find the probability of event A or event B occurring, determine if the events are mutually exclusive, then use the addition rule. If the events are mutually exclusive, they do not overlap, just add up the probabilities. If they are not mutually exclusive, they do overlap, then add the probabilities and subtract the overlap. That's it for this video. Thanks for watching.